Good morning, everybody. This is Sunday, it's November 14th, and we are moving into week 12, module 12 of our online astronomy course. Hope you've all had a good week and a lot to tell you about. And the first thing I want to tell you about is that this coming week, you have your third exam. The exam opens on Monday, November 15th, and runs through the next Sunday, November 21st. So you can take it anytime during that time period. You can take it twice if you want to. The format will look very familiar. It's exactly the same, 35 multiple choice questions. You get 2 tries. If you take it once, you can see what answers you missed. Make sure you know the answers and then take it again. Look up what you missed in your book or in the homework. And of course, you can always look at the homework quizzes while you're taking the exam. That's certainly fair. But those are the only resources allowed, is your book and your homework quizzes. So good luck. If you have any questions about the exam, let me know. And especially if you have any trouble taking the exam, let me know if there's some problem with computers or something. So good luck on that. And let's see what else is going on. Oh, there's some really cool astronomy news I want to tell you about. There is an array of radio telescopes down in the Atacama Desert in South America, and it has seen a moon that's actually forming around a new planet, around an exoplanet, around another star. So there's a moon forming around a planet, which is forming around another star. And rather than tell you this, I want to share the screen and show you a short video. It's pretty cool. So let me just share the screen here, and we'll watch this video about this newly forming planet. Those are the radio telescopes. Well, I thought that is pretty cool, seeing a disk that is forming a moon around an exoplanet. It is really amazing what we can see with those radio telescopes. All right, well, we're moving into module 12, and it's about our Milky Way Galaxy. And finally, on the very first day of our class, you saw this background, and there, right behind me, over my shoulder, is our Milky Way Galaxy. And finally, we get to talk about it. Galaxies are something altogether new that we haven't talked about before. These are collections of hundreds of billions of stars. Our Milky Way has hundreds of billions of stars in it, and it is truly huge. We can't, we measure distances to stars in parsecs. The nearest star is a little bit over, the nearest star other than the sun, I should say, is a little bit over a parsec away. Now, to talk about distances within our Milky Way galaxy, we have to talk about thousands of parsecs, that is kiloparsecs. In the same way, a kilometer means 1,000 meters, kiloparsec means 1,000 parsecs. And the kiloparsec is about 3,260 light years. So when you look at that Milky Way behind me, first of all, if you were really out there, you would find that not only could you look up at the Milky Way, but you would find that the Milky Way stretches all across the sky from one side to the other. The Milky Way completely encircles our solar system. And why does it appear like that? Why does this appear like a ring around us? It's because the Milky Way has the shape of a disk. Our galaxy and other galaxies like ours, which are called spiral galaxies, are in the shape of a disk. And so if here is my plate, looks round, but if I hold this up, you can see it's sort of in the same direction as the Milky Way is in the sky right there. And because I'm looking along the edge of that plate, I just see a little band that I'm looking at. I just see the edge of the plate, just like you, when you're outside, are looking along the edge of the Milky Way. Now, right now we are looking, at least in this picture, we're looking toward the center of our Milky Way galaxy. I'll move aside so you can see it a little bit better. We're looking toward the center of our Milky Way galaxy. And where are we in this Milky Way galaxy? If you could see it, it would be a circular, a disk like this. And the distance across the Milky Way, is about 30,000 parsecs, about 30 kiloparsecs, and that's like roughly 100,000 light years. So where are we? Are we at the center? And the answer is no. We are about 8 kiloparsecs from the center. So right here, I would have to go about a quarter of the way out toward from the center. And so the sun, well, actually it's about 15 from the center to the edge. And so the sun is about halfway out toward the edge of our galaxy. So we're in the suburbs, and it takes, our sun and our solar system is slowly orbiting the center of our galaxy. And it takes about 220 million years for the sun to go once around our Milky Way galaxy. So just think, it's hard to, what does 220 million years mean? Well, 220 million years ago, Earth, its land masses were in one giant landmass that was called Pangaea. That landmass was beginning to break up. We were just entering the Triassic Age. The Permian extinction, the Great Dying, as it's called, was about 30 million years before that, and Earth's life was just recovering. About 80% of sea life was wiped out. About 70% of land life was wiped out at that time. And that was because there were a number of volcanoes that erupted in what is now Siberia. And those volcanoes covered a land area. How to describe that land area? Well, if you drew a line north-south through Salt Lake City that went up to the Canadian border and down to Mexico, all the land in the US from that line over to the Pacific Ocean is how much area those volcanoes covered. And they just dumped an incredible amount of carbon dioxide into our atmosphere. And that caused a huge warming. It made the oceans toxic. The oceans could no longer have oxygen in them. That affected all the photoplankton in there that produce oxygen, and there was a mass dying off. That was about 251.9 million years ago. So by the time that we were last here in our orbit around the Milky Way, 220 million years ago, Earth was beginning to recover and was well underway in recovering from that awful, awful mass extinction. How old is our Milky Way? You know, our Milky Way is about 13 billion years old. Now the sun is only 4.5 billion years old, 4.5, 4.6, something like that. And so our Milky Way has been around for much, much longer than that. And I have to tell you, that makes me think, you know, we just looked at that video about a planet and its moon forming around a distant star. Maybe there's somebody out there who developed intelligent life before we did, and they have those sort of pictures of the formation of our solar system. Wouldn't that be amazing? Something cool to think about. But you know, how did the Milky Way form? How did the Milky Way form those 13 billion years ago? Well, like stars form, there was a collapse of a cloud of gas and dust, a huge cloud of gas and dust. And that cloud of gas and dust formed parts of galaxies. And those galaxies, those young galaxies, collided with each other. And from those collisions, our Milky Way and a lot of other galaxies were formed. And those galaxies collisions are still going on. In fact, Andromeda, and the Andromeda Galaxy, called M31, is the name in the Messier catalog. And the Andromeda Galaxy is the closest spiral galaxy to our own Milky Way. And it's going to collide with our Milky Way in about 5 billion years. Now, the stars aren't going to collide, but what will happen is that although the stars don't collide, the gas and dust between the stars will collide. And that will cause a round of new star birth and all sorts of fireworks. So it'll be pretty interesting around here about 5 billion years from now. Wow, just amazing. Now, you may be wondering, how can we know all this? How can we tell the shape of our Milky Way galaxy? I mean, here we are, we're living inside of this disk that's oriented like so. So we're just looking along the edge of the Milky Way. How can we know how large it is, for instance? How can we know that? Well, that all started at the near the beginning of the 20th century with a man named Harlow Shapley. And you know, all the stars in the sky that we can see out here, all of those stars belong to our Milky Way galaxy. And Shapley, an astronomer, studied those stars, and he noticed that there were globular star clusters. These are small balls of up to a few million stars. And he noticed that these star clusters were all gathered just generally in one part of the sky. And they were gathered right about here. If you can look past my head to the Milky Way, that's where he saw them. And those globular star clusters contained Cepheid variable stars. And so he used the period luminosity relation that was discovered by Henrietta Swan Leavitt to discover the distances to those stars. And he was able to map them out. And he found those globular star clusters formed a big ball in space, a big spherical ball in space. And the only thing that made sense was that the center of that ball was our Milky Way Galaxy. The center of our Milky Way at the center of that ball. And so that's how I figured out that our sun is about 8 kiloparsecs from that center. Pretty cool, pretty cool. So there's a lot you have to learn about the Milky Way, and I'll mention just one more thing, and that is what is lurking at the center of our Milky Way. In fact, right over my shoulder there, right over my shoulder in the center of the Milky Way, you'll find out that there is a supermassive black hole. A hugely massive black hole. And you'll find out all about that in this module. Now, there's one more piece of news I have for you. And so I want to share the screen. So let me pull up something here, and I will share this. And that piece of news is that this week there's going to be a almost total lunar eclipse. And you can see it. It starts here in Salt Lake City, at least in this time zone. It starts, you can see down here, I'll just pull down a little bit. It starts around 11:02 p.m. in the night of Thursday, November 18th. And that's when the moon just starts to begin to enter Earth's shadow. Now it enters the darkest part of Earth's shadow, the umbra, at 12:18 a.m. That is very early Friday morning on the 19th. And it gets most deeply, the moon gets most deeply into Earth's shadow at 2:02 a.m. early Friday morning. And that's when the maximum eclipse is going to be. And as you can see from this, this diagram here, the only part that's outside the umbra so that there's some partial sunlight hitting it is just this little sliver of the moon. So this is really going to be spectacular. And in fact, there was a similar eclipse last May, and I went out and took a picture of it, photo of it. And here it is. And this was taken around about dawn, very close to dawn. The skies were cloudy, so you were looking through thin clouds. And in fact, the moon just peeked out between the clouds, and I got this photo. And here you can see this little sliver of partial sunlight that's hitting the edge of the moon. And the rest of the moon is deeply within the umbra of Earth's shadow, the darkest part. And all of the sunrises and all of the sunsets all over Earth are spilling onto the moon, and they are making the moon appear red. Now here, the dawn is fast approaching. Those colors are sort of washed out. But this week's eclipse is going to be happening just maximum a little bit after midnight. So the moon's going to be high in the sky, just a little bit west of south. And you'll have no trouble seeing that in the sky. And so let me show you just where that is. I'm going to pull up Stellarium. And there's the night sky. This is at 2:02 a.m. early in the morning on November 19th, Friday. And you can see here is Orion, great constellation of Orion. Here's the Orion Nebula. For right now, there are stars being formed. Excuse me. Here's the red giant star Betelgeuse. And over here there is the moon, which is deep into its eclipse. Now you can't see that very well. So what I'm going to do is just pull the moon down to the center of the screen and zoom in on it. And there's what the moon will look like at maximum eclipse. You can see just a little sliver of sunlight where it's peeking out of the umbra, and the rest of this is going to be in Earth's umbra, and you can see that reddish color it has. It is really going to be spectacular, and especially with Orion and everything arranged around it. So I hope you go out early in that morning of this Friday and take a look for yourself. So, a lot of cool stuff to see this week. Very interesting things in Module 12, and I hope you enjoy learning about them. Good luck on the exam. And as always, if you have any questions, all you have to do is contact me through discussions, send me an email. I'll be happy to set up a Zoom meeting with you, or we can meet in person in my office. So have a good week, and I will look forward to seeing you next time. And so until then, bye-bye.